Hello my dear students, welcome to the lecture Unit 2 Statistical Quality Control. In this video, we are going to discuss problems in control charts for variables. So the first problem is, a machine is set to deliver packets of a given weight, 10 samples of size 5 each were recorded. Below are given relevant data. So in this data, we are given the sample number. So the sample numbers are 10 samples in this problem and the corresponding means and ranges are given. Now we have to find out the values for central line and control limits for mean chart and the range chart, and then comment on the state of control. So here in this problem, the number of samples. So the number of samples can be denoted by the letter K. So K is equal to 10 and size of the each sample is 5. So that size of the each sample can be abbreviated as small n. So small n is equal to 5. So and this is the given data. Now we have to find out the central line and the control limits for mean chart. So first of all, we have to find out X double bar and R bar values. Now the solution of this problem is, so here we are given the number of samples, that is K is equal to 10 and size of the each sample is 5, that is the small n is equal to 5. So from the above data, we get X double bar. So X double bar can be obtained by summation I is equal to 1 to K Xi bar values divided by K. So in our problem, so these are the mean values of 10 samples. So sum of these 10 values. So sum of these 10 values, we get the summation value is here 162 divided by the number of samples are here 10. So 162 by 10, this is 16.2. And also we have to find out the average of range value, that can be denoted as R bar. So now R bar is equal to summation I is equal to 1 to K Ri divided by K. So these are the range values. These are the range values of the 10 samples. So sum of these range values. So all values are summing together, we get the summation value here 74. 74 divided by the number of samples are here 10. So 74 by 10 we get 7.4. In this slide we have to find out X double bar and R bar. So the X double bar value is 16.2 and R bar value is equal to 7.4. In the next slide, we have to find out the control limits for the mean chart. Now we set up the control limits for mean chart. So the 3 sigma control limits for mean chart, that is X bar chart, are, so the upper control limit UCL is equal to, formula is X double bar plus A2 R bar. So X double bar value, so that is 16.2 and the value of A2. So for n is equal to 5. So the size of the sample in this problem is 5. For n is equal to 5, the value of A2 can be obtained by the statistical quality control tables. So the value of A2 is from the statistical quality control tables, that is 0.577. So here we have to substitute the value of A2 here, that is 0.577, and the R bar value is 7.4. So by the simplification of these values, we get 20.4698. So this is the upper control limit value and the lower control limit. So the lower control limit can be expressed as x double bar minus A2 R bar. So the x double bar value is 16.2 minus A2 value is 0.577, and the value of R bar is already we are calculated in the previous slide, x double bar and R bar values. X double bar value is 16.2 and R bar value is 7.4. So by subtracting these two values, we get 11.9302. And this central line, that is CL, that is equal to x double bar. So this x double bar value is 16.2. So these are the control limits for mean chart. So UCL is 20.4698, LCL is 11.9302, and CL value is 16.2. Coming to the next slide. So here we have to construct the control chart for mean values. So these are the UCL and LCL and CL values, and so this is our given problem. So these are the 10 samples corresponding mean values. Now we have to construct the mean chart. So x-axis, we have to take the sample number. So here we are given 10 samples. So 2, 4, 6, 8, 10. So this is x-axis. In the y-axis, we have to fix the scale based on mean values and these control limits values. So we have to fix the scale on the y-axis. Here we have to take the values 5, 10, 15, 20, 25. So this is y-axis, and y-axis represents mean values or x bar values. So first we have to plot the control limits. So first one is the upper control limit value is 20.46, 20.47. So here the point value is here. So here we have to draw a horizontal dotted line. So this is the upper control limit. So this value is 20.4698, and the lower control limit value is 11.93. So I am plotting the point, LCL point on y-axis, and based on that point I have to draw the horizontal dotted line. This is LCL. So this point is 11.9302, and the CL, so this is 16.2. So I have to draw a solid horizontal dark line. So this is a CL, this is 16.2. So these are the three control lines, and we have to plot the mean values corresponding each and every sample. In the first sample, corresponding mean is 15. In the second sample, mean 17. Third sample, 15. In the fourth sample, this value is 18. And is fifth sample, this is 17. And the sixth sample, the value is 14. And the seventh sample corresponding mean is 18. In the eighth sample is 15. In the ninth sample, the value of mean is 17. And the 10th sample, the value of mean is 16. Okay, so we have to observe all these sample mean values. So this is the sample mean values, that is x bar values. This is x bar values. So here all the sample mean values fall within the 3 sigma control limits. Then the process is in statistical quality control. So here all the sample points. So those points are x bar values, fall within the 3 sigma control limits. Then the process is in statistical quality control. Next chart is range chart. In this first problem, now we have to set up the control limits for range chart. So the 3 sigma control limits for the range chart, that is R chart, those are, so the upper control limit is equal to D4 R bar. So this is the formula for upper control limit. The lower control limit LCL is equal to D3 R bar, and the central line CL is equal to R bar. So for n is equal to 5, the value of D3 is 0 and the value of D4 for n is equal to 5 is 2.115. So these values are obtained from statistical quality control tables. Now we have to substitute these values in the control limits formula. Then UCL is equal to D4 value is 2.115 into R bar value is already we are calculated, that is 7.4. So by the multiplication of these two values we get 15.651, and the value of D3 is 0. 0 into R bar value, that is 7.4. 0 into anything, we get the value of 0. And CL, that is R bar, this value is 7.4. So these are the control limits for range chart. Now we have to construct the range chart. For these 10 samples and the corresponding range values and the 3 control limits values. So in the x-axis, we have to take the sample number or number of samples. In y-axis represents the range values. Here we have to take the range values 3, 6, 9, 12, 15. So the maximum value is here 15. Okay, this is y-axis. Y-axis represents the range values, that is R values. Now we have to plot the UCL, LCL and CL values. So the UCL point is 15.651. So this is the UCL point. So based on that point, I have to draw a horizontal dotted line. So this is UCL. So this value is 15.651 and the LCL is 0. So x-axis is LCL. So this is 0 and the CL value is 7.4. So here the CL point, that is 7.4. So CL line is always drawn as a dark horizontal line. So this is a CL. So this is 7.4. Now we have to plot the range values corresponding each and every sample. In the first sample range is 7 and the second sample range value is also 7. So this is a 7, first sample, second sample is value is also 7. In the third sample range value is 4. And the fourth sample range value is 9. And the fifth sample range is 8. And the sixth sample range is 7. In the seventh sample, the range value is 12. Eighth sample range is 4. And the ninth sample range value is 11. Okay. And the 10th sample range is 5. So here we have to observe all the sample points, that is the range values. The range values within the control limits. Then our chart shows that the process is under control. So since both X bar and R charts indicate control. So the process can be regarded to be in statistical control. Regarded to be statistical control. So this implies that the process is operating free from assignable causes of variation and is under the influence of only chance causes of variation. So this is the first problem. And the second problem is a manufacturer wished to test the life of cells. Conforms to standards, the cells will be considered satisfactory if their life is 25 hours with a standard deviation of 2 hours. A sample of 5 cells was drawn daily for 12 consecutive days. The data of life of cells are given below. So this is the given data for 12 days. So in each day they are collecting 5 observations. So these are the life of cells. So these values are given in hours. So this is our given data. Now we have to find out. So in this problem we have to solve the 4 types of methods. So first one is calculate the 3 sigma control limits for the control chart for X bar when the value of mean of the universe is 25 hours and the standard deviation is 2 hours. And in the second question, set up the control limits for X bar chart when the standard values for mean and standard deviation are not known. Also prepare the control chart and comment whether the process is under control or not. In the third question, so we have to construct the sigma chart when the specified values for standard deviation are not known. So that means the standard value of the sigma chart is not known. Then we have to construct the sigma chart. So and in the fourth question, draw a range chart when the standard values are not specified. So first we have to find out the first question. So calculate the 3 sigma control limits for X bar chart when the value of mean of the universe is 25 hours and the standard deviation is 2 hours. So this means we are given that mean of the universe, that is mu dash value, that is equal to 25 hours, and sigma dash standard deviation value is given value, that is sigma dash, this value is equal to 2 hours. So then the 3 sigma control limits for X bar chart. So those are UCL is equal to mu dash plus A into sigma dash. So the value of mu dash is here 25 plus the value of A can be obtained from the statistical quality control tables. So for the size n is equal to 5, the value of A value is 1.342. So we have to substitute. So 1.342 here and the standard deviation value is 2. So by the simplification of these values, we get to 27.684. And next one is the lower control limit. Mu dash minus A into sigma dash. So the value of mu dash is 25 minus A value is 1.342 and the sigma dash value is 2. So we get 22.316 and the value of CL. So this is the average value, that is mu dash. This is equal to 25. So these are the control limits for the control chart for X bar when the values of the mean and standard deviation values are known values. Then these are the 3 control limit values for X bar chart. To construct the control limits for mean chart and standard deviation chart and range chart, we have to prepare some of the calculations. Those calculations are in this table. So first you have to find out the mean values for each and every sample, that is the x bar values. How do we get the value of x bar? So sum of the observations in that sample divided by the number of observations. So the first sample observations are 27, 28, 25.5 plus 26.5 and 23. So we have to add those 5 values divided by 5. We get a 26. In the similar way, we have to find out the remaining sample mean values. So, and the second sample mean is 26.6, 26.7, 27.5, 26.1, 26.6, 24.5, 26, 28.2, 25.2, 25, and the last sample mean is 28. So, and in the next column we have to find out the range values. How to get the range value? The maximum value in that sample minus the minimum value in that sample. So first we have to find out the first sample range. In the first sample, the maximum value is 28 and the minimum value is 23. So difference between 28 minus 23. So that is we get the value of the range. So that is 5. In the similar way, we have to find out the remaining sample range values also. That is 5.5. So in the third sample range is 3.5, 2, 3, 1.5, 7, 3, 3.5, 4, 5.5 and last value is 4. And next column we have to find out the standard deviation values, that is the S value. How do we get the standard deviation value? The positive square root of the arithmetic mean of the squares of the deviations of the given values from their mean. That means in the first sample here we have to show the value of standard deviation. How do we get? The positive square root of, so the first sample observation is 27 minus the corresponding mean is, in the first sample mean is 26 whole square plus next sample observation is in the first sample. Next observation is 28 minus 26 whole square plus, and the third observation is 25.5 minus the mean value is 26 whole square plus 26.5 minus 26 whole square, and the fifth value is 23 minus the mean value is 26 whole square divided by 5. So we get the standard deviation value for the first sample, that is 1.70. So in the similar way, we have to find out the remaining samples standard deviation. In the second sample, standard deviation value is 1.83 and the third value is 1.21, 0.71, 1.24, 0.58, 2.65, 1.26, 1.36, 1.44 and this is 2 and the last value is 1.41. So here we have to find out the total values for the column X bar, R, S. So we get summation X bar is equal to the total of X bar column is 316.4 and the total of the range values for 12 samples, that is summation R. So this summation R value is 47.5. And in the last column, so you have to add the total standard deviation values for 12 samples, that is summation S value. So summation S value is 17.39. So based on these values, we have to find out X double bar. Here we have to find out the X double bar value is summation X bar divided by the number of samples, that is 12. So 316.4 divided by 12, we get the X double bar value, that is 26.3666 something. So we have to write down 26.37. So, and we have to find out R bar value. So how do we get the R bar? Summation R divided by K. So here the number of samples are 12. So that is 47.5 divided by 12. We get the range R bar value. So sample range value. So average of the range value, that is R bar, that is 3.9583. So in a similar way, we have to find out average of sample standard deviation, that is S bar. So this is summation S divided by K. So that means 17.39 divided by 12, we get 1.45. The second question, set up the control limits for X bar chart when the standard values for mean and standard deviation are not known. Also prepare the control chart and comment whether the process is under control or not. So we have to set up the control limits for X bar chart. So we are required X double bar value and S bar value. So the value of X double bar is 26.37 and the value of S bar value is 1.45. We are calculated in the previous slide. Now the solution of this problem is when mu and sigma are here unknown values, then the 3 sigma control limits. The 3 sigma control limits are UCL is equal to X double bar plus A1 into S bar, and the formula for LCL is equal to X double bar minus A1 into S bar, and the CL is X double bar. Now we have to substitute these values in this expression. So now UCL goes to 26.37 plus the value of A1 can be obtained from the statistical quality control tables. So for n is equal to 5, the value of A1 is 1.596. Here we have to substitute the value of 1.596. The value of S bar is 1.45. So by the simplification of this expression, we get 28.6842. And LCL is equal to the value of X double bar is 26.37 minus 1.596. This is the value of A1, and the value of S bar is 1.45. So by the simplification of LCL expression, we get 24.0558. And CL is X double bar, that is 26.37. So these are the 3 sigma control limits when the standards mu and sigma are unknown. So these are the control limits for X bar chart. Now we have to construct these values in this chart. So in the x-axis, we have to take the sample numbers 2, 4, 6, 8, 10, 12. So here we are given 12 samples. So the number of samples are 12 here. And in the y-axis, we have to choose the scale. That is, so here we have to take 20, 22, 24, 26, 28, 30. So y-axis represents mean values, that is x bar values. In the first sample, mean value is 26. We have to plot the value 26 here, and the second sample mean value is 26.6, and the third sample mean is 26.7, and the fourth sample is 27.5, and the fifth value is 26.1, and the sixth value is again 26.6, and the seventh value is 24.5, and the eighth value is 26, and the ninth value is 28.2, and the 10th value is 25.2, 11th value is 25, and the 12th sample mean value is 28. Now we have to plot the control lines. So the first UCL point, that is 28.68. 28.68. So this is UCL. This is 28.6842. And the value of LCL, that is 24.05. This is LCL. This is 24.05, and the CL is 26.37. So here we have to observe the sample mean values, sample mean points. All the sample mean values are in the 3 sigma control limits. So here we are writing the interpretation, that is, since no sample point fall outside the control limits, we conclude that the process is under control. So this is the second question. And next, third question. Construct a sigma chart when the specified values for standard deviation are not known. So in this construction of sigma chart, we are required the value of S bar. So the value of S bar is 1.45. So this value we are calculated in the previous slides. Now the 3 sigma control limits for sigma chart. For sigma chart, those are UCL is equal to B4 S bar. So B4, the value of B4 can be obtained statistical quality control tables for n is equal to 5. So based on the sample size n is equal to 5, the value of B4 is 2.089 and the value of S bar is 1.45. So by the multiplication of these two values, we get 3.02905. And next one is LCL, that is lower control limit. So the lower control limit for sigma chart is B3 S bar. So the value of B3 from statistical quality control tables, so this value is 0 into S bar, that is 1.45. So 0 into anything we get 0. And the value CL, CL is equal to S bar. So the S bar value is 1.45. So these are the 3 sigma control limits for standard deviation chart, that is sigma chart. Now the construction for the sigma chart. So for the construction of a sigma chart, we are required the standard deviation values for 12 samples. So in the previous slides, we are find out the standard deviation values for each and every sample. So these are the standard deviation values for 12 samples. So here in the construction of sigma chart, we are using this standard deviation values. So here we have to take the sample number on x-axis. We are given the samples, here 12 samples. So these are the number of samples. In the y-axis, we have to choose the standard deviation values, that is SI values. So based on those values, I am choosing the suitable scale, that is 1, 2, 3, 4 and 5. So first I have to draw the upper control limit, lower control limit and central line. So the upper control limit value is 3.02. 3.02. So this is the point. I am drawn the dotted line for UCL 905. So the value of LCL is 0. So 0 means x-axis is LCL. And this central line, this is 1.45. So this is a dark line for CL. We have to draw. This is 1.45. Now we have to plot the standard deviation values for each and every sample. So in the first sample, standard deviation is 1.70. And the second value is 1.83. And the third value is 1.21. Fourth value is 0.71. And the fifth value is 1.24. And the sixth value is 0.58. Seventh value is 2.65. and the 8th value is 1.26. 9th value is 1.36 and the 10th value is 1.44 and 11th value is 2 and the 12th value is 1.41. So here we have to observe the sample standard deviation values. So these are the SI values. So no point falls outside the 3 sigma control limits. We conclude that the process is under statistical quality control based on the standard deviation chart. So here under statistical quality control. So the process is under statistical quality control in this question. Fourth question. Draw a range chart when the standard values are not specified. So here we have to write down the control limits for range chart. So the upper control limit. So here in this range chart, the standard value is unknown. So when the standard is unknown, we are writing the 3 sigma control limits for UCL. So those are D4 R bar. So the value of D4 from statistical quality control tables, this value is 2.115 and the value of R bar is 3.96. So by the multiplication of these two values, we get 8.3754. And next, the lower control limit is equal to D3 R bar. So the value of D3 for n is equal to 5. That value is 0 from statistical quality control tables. 0 into R bar. So that is 0 into 3.96. We get 0. And next one is the central line. This is R bar. And this R bar value is 3.96. So when the value is not specified, that means the standard value is unknown, we are writing the upper control limit D4 R bar value is 8.3754, lower control limit, that value is D3 R bar value is 0, the central line, so this value is R bar, so this value is equal to 3.96. And in the next slide, we have to draw a range chart. So for the drawing of the range chart, so we are required the range values for the each and every sample. So in the x-axis, we have to take the sample number as usual. So here we have to take the number of samples. In our problem, we are given 12 samples. So here 1 centimeter is equal to 2 units. In the y-axis, we have to fix a suitable scale based on the range values. So here I am writing 2, 4, 6, 8, 10, 12. So in the y-axis represents range values, that is Ri values. So first we have to draw the lines. The upper control limit value is 8.3754. So we are plotting the point on y-axis 8.3754. Based on that point, we have to draw a horizontal dotted line. This is UCL. This is 8.3754. The LCL value is 0. So that is x-axis. And the value of CL is 3.96. So 3.96. Based on that point, I have to draw a solid horizontal line. So this is a CL. This is 3.96. And next we have to plot the range values for each and every sample. So the first sample range is 5 and the second sample range value is 5.5 and the third value is 3.5. Fourth value is 2. Fifth value is 3. And the sixth value is 1.5. Seventh value is 7. Eighth value is 3. Ninth value is 3.5. 10th value is 4. 11th value is 5.5. And the 12th value is again 4. So here we have to observe the sample range values. So these are the sample range values and points also. So here sample points, that is the range values of all subgroups, lie within the control limits, then the process is under statistical quality control. So since the sample ranges of all subgroups lie within the control limits, then the process is under statistical quality control. So this is the problem. Thank you.